Hi, in this video we are going to look at the compound waveform. The compound waveform is a wrapper around four partial waveforms that we looked at in the previous example. And it has its own three value converters that if you use them, that change value will be fed to all four of these partial waveforms. Then you have three different operations that combine the output from these partial waveforms, and then that combined output can be put through three value converters belonging to the compound waveform. What is special about the compound waveform is it has an alternate flow that you might need to use sometimes. To be honest, in most cases I use this default flow. In the default flow, the output from partials 1 and 2 is processed by operation 1, and the output from partial 3 and 4 is processed by operation 3, and then the output from operation 1 and 3 is then put through operation 2. Here you see this alternate flow through the compound waveform, where the output from partial 1 and 2 is still processed by operation 2, but then operation 1, and then operation 2 will process the output from operation 1 and partial 3, and operation 3 will process the output from operation 2 and partial 4. But let's have a look at this in the software. I right click and I choose to create a compound waveform. As you can see here in the top, we have the three partials, then we have the three operators, and finally we can choose that flow I talked about, and it has its own phase converters and value converters. Let's quickly set it up to the most basic waveforms. Here for the first we choose a sine. Here for the next I choose a triangle. For the third, I choose a square. And for the fourth, I choose a saw. Right now you only see the output of the first one, and that's because all of these operators have been set to left. You see the operators is placed in a group box, and that group box is below 2 of the partials, so you can see which operator it's working on which partials. So seen from the perspective of operator 1, then partial 1 is the left and partial 2 is the right. So that's the reason that when we choose left, we are seeing this one. Whenever you choose an operation, you will see a small icon up here. So when left is chosen, you see this arrow pointing left. When right is chosen, you see this arrow pointing right, and that's the reason we now change to this one. And so on, scrolling through them, you will see, of course, you'll see different results here, but you'll also see a different indication up here. And we'll go through all of those operations. You have below each partial, beside the edit button that will let you dial in and set up that partial, you have these buttons. The first three are copy, the next three are swap, and this is a clear command. And you can, instead of setting up the waveform as I did here, if you already have a waveform you want to use from the database, you can simply use this one and you can load in a waveform. For example, if I want to swap this one with the second, I can simply click here, swap with 2, and press again to swap back. Or if I want to swap with the third, I can do that. And also if I want to copy it instead of swapping, I can say I want to copy waveform 3. So I press this button here, and then it's changed to this one. In all of these forms you can use Control C and Control Y to redo and undo, so I can simply redo to go back. So this is the basic operation of this compound waveform, and each of these have their own phase and value converters, but you also have phase converters here. For example, if I want to say I want to produce a split between these two, and then I want to add for example, a peak wrapper, I can do it and get that combined result then with the peak wrapper applied to it. For the next part of this video, I will go through all of the operations, and in most cases I will only describe that operation with two waveforms, partial 1 and partial 2. So let's clear out number 3 and number 4. And as we saw already, the left chooses the left waveform. And also here you see we choose left and left. And if you remember that diagram, it hopefully makes sense, but otherwise it's listed here that partial 1 and partial 2 are processed by operation 1, and you have that in a parenthesis. And then you have partial 3 and partial 4 that is processed by operation 3. You have it here. And then finally, operation 2 will work on the output from operator 1 and operator 3. And that's why this one is highlighted in orange. It's the last in the row that's processed. If you change to this alternate output that you also saw from the illustration in the manual, this orange one shifts to the last one. So you can see that you do something on two waveforms, then you do something else on two other waveforms, and then you merge these two together in some way. And there's no difference otherwise from these operators. These operations you have are the same in all three. Next, we have the right, and it does the same as before. Now, from these two, I choose the right one, being the partial. As I said, the very last to be performed is this operation 2, and it's set default to left. And when that's the case, it completely ignores what's happening in partial 3 and 4. If I change this one now to right, remember this is the last one of these that are performed. So now we completely disregard what's happening over here, and we only see what's happening here. So if I choose in, for example, a saw, now it's a saw I see. If I choose here, let's choose a square, I still see the saw, because this one, say we need the left one, setting this one to the right one. So now the output of these is the right, and then lastly this one choose the right, so it's the output from this operator. Let's set them back to left and clear these and set this back to left. So we are only going to look at these two partials. Next in the line is the split. As you can see, the split operation performs a very quick split here in the middle. You cannot define where the split is. If you need to define a split, where the split is, you need to do it in the partial waveform. But here you simply split in the middle, and you can dial in that transition. For example, if I set this to a square instead, I can dial in a transition to gradually switch from one to another, and you have different ways to do it. In this case, I would use either this one or this one. I'll probably go for this one. So it's a more simple split than you can do in the partial, but it's very quick to do. Next we have the interchange, and I think I'll go back to the triangle again, or perhaps do a saw. And then instead of a simple saw, I'll do a saw with some harmonics. Right now we only see the left as indicated by this arrow. But if we do the interchange, defined by an I, we are splitting up our waveform in 3 sections, and then it simply alters between those 4 sections. And we see the first section is from the sine, the next is from our saw, then this one from a sine, and the last one from our saw. And you can choose how many sections you want. If we go back to, let's set it to 8. Right now, when it say fixed, the order is fixed. It will alter between the sine and the saw all the time, and also their size is fixed. You can dial in to set it should be, it should alter. We are still altering between the sine and the saw, but now the size of the segments are random. And you see this SD1, it means it's seed value 1. And then simply scrolling through them, we have different seed values, so you'll see different sizes of these. It will not be a fixed size, it will be a random size chosen for each segment. If we scroll further down to the lists, after seed value, it will change from alter to random. And when it changes to random, it will no longer alter between partial 1 and partial 2. It will be completely random which partial it will take for the next section. So if you start counting here, you see 1 section, 2, 3, 4, 5, even though we have selected 8. And there are actually 8 sections here, but as they're selected completely random, this first part could be 2 sections next to each other, and perhaps this one also 2 sections next to each other, taken from the same waveform. And again, you have 100 different seed values to randomize. So you will get completely different results. Also, you'll see it's not always starting with the sine. The first segment is also random, so sometimes it will start with the sine, sometimes it will start with the saw. Here, apparently, even though we have 8 sections, apparently only 1 is selected from the sine, but as I said before, it's split. Even though we cannot see it, it's split into multiple sections. And you can go very high, and you see a result like this. If we go back to fixed, so they have the same size, you get this effect. So that's the interchange operation. Next, we have the replace. And the way it works is we define a range, and then that part of the waveform is, it will replace partial 1 with the contents of partial 2. Here we are replacing from 90 degrees to 270 degrees. But naturally these can be changed, so you can choose exactly what you want to replace. So that's the replace. It's very simple what it does, but it can have a huge effect depending which waveform you're replacing with what waveform. The next operation is the mix. And think of it as you moving 2 faders on a mixer, where you gradually fade out one of these waveforms and gradually fading in the next one. And this mix type simply chooses how that curve is you're moving those sliders, how quick they change. I prefer the effect of this S-curve, and that's why it's a default, but you are free to choose the linear. And right now, we have 98% the volume from the first particle and only 2% from the next. So this assembles the sine, but as we gradually fade one in and fade one out, we get this effect. And if this is exactly the waveform you want, you can choose to add a volume value converter and dial in a higher volume. But as I said in the other videos, you don't have to, because when you export this waveform, it will automatically be normalized to this volume. Personally, I would add it because I like to see the volume in its full range. So I would add this one, but it's not necessary to do so. So this is the mix operation. Next, we have the multiply, and we simply multiply each value from one particle with the same value taken at the same phase from the other one, and we get this effect again. In this case, I would add a volume and increase the volume so I can see the full range. If we choose another one, as you might remember, I had these different waveforms here called multiplication ramp and multiplication jitter. And the reason they were called so is I said they were great for use for multiplication. And the reason for that is they only have a signal here in the positive part of the waveform. They will not change negative. So now when I use this one to add, you see I will gradually add more and more jitter to the waveform. You can choose this one. It's not important that it's positive, because this combo box lets you choose how it's multiplied. Here we take the raw values from the left, so we both have positive and negative values, and it defaults to this one absolute of right. It means negative values here would be turned to positive values. You can also do you want to turn this one into a positive, then we don't have this part down here negative, it will be up here, and that's why the result will be like this. Or you have this one where you take the absolute left and right, meaning you multiply the left with the right, and then you take the absolute, the positive value of that, or simply multiply them without changing the sign of them. So this is the multiplier. You can do some nice effects. For example, if we add the frequency to this one, let's do 12, and we change this one instead to the multiplication ramp and say it should go up and down, and we want to do it for example like this, we get this result. Also, we could just do a ramp up and say it's a linear, and let's dial in a square here instead. And let's raise the so you can do many things with the with multiplication. Let's go back to our triangle and our sign. Next we have an add, and when you add two waveforms, it will simply lower the volume by half. Depending on the waveform you have, you might get some air in the top and the bottom, and again you could choose to add a value converter for volume if you want to. Next we have the subtract. Add in would simply subtract this waveform from this waveform, and here I would choose to add the volume, but as I said before, it's only a visual thing. the volume value converter only goes to 500%, and in this case it's not enough. So I would simply add another. Normally I will go until I see this asterisk telling me I have a soft clip, that I have something that's not being displaced. And I would dial it back 2 times just to give myself a little headroom. But again, it's only visual. It's when you export this waveform, even though we had not added these volume converters, this was how it would be exported, as the waveforms are always normalized on export. So let's remove these two. Next in line is the Phace-Inject. And it's probably one of those that's a bit difficult to understand. I will change this one into a hand drawn. And I will simply draw a line like this. And now we just see the sign as it is. The way it works is this waveform is used to extract values from -1 to +1. And instead, this waveform is used to inject phase values into this one. Here, where the value is -1, pretend the phase is injected from below, and you go up to the waveform and then go to the right, and then you read the output phase from here. So here, when it's 1, when the phase is 0, and we get this value -1, that -1 will be changed to a phase of 0 degrees. If we go up here and we go here, that phase value, input value of 90 degrees will also output as 90. Here input value of 180 will be output as 180, and so on. And when we draw this diagonal line, that's when we see this exact replicate of the sign, because it gradually go from 0 degrees to 360 degrees. However, if we change this waveform, if we do like this instead, it means it will go through from 0 degrees to 360 degrees in the first 270 degrees of the phase, and then the last 90 degrees it will go in the opposite direction from 360 degrees and down to 0 degree. So now we inject this changed phase transition into this waveform, and we get this result where we see the full sine in the first 270 degrees, and then in the last 90 degree, we see this reversed or an inverted version of the sign. What we could do also is we could add 4 different transitions. For example, start with a linear, or let's just do 4 linear to begin with. And now, I don't know if you can guess the result, but we have simply increased the frequency of the waveform, so now we have the sine 4 times. What we can do now is we can change how it transition. Instead of linear, we can draw an S-curve. Or we could do an ellipsoid like that, and we do another ellipsoid where I press shift and we do it the opposite. And now we get this one. We still have 4 signs, but each of them look different. The first one, we have a linear transition, so the sign will look as it is. This next one with an S shape, it will climb more slowly in the beginning, then it will speed up, and then the last part it will gradually slowly transit into this one. Here with the ellipsoid with this convex shape, it would quickly grow to the height, and then it will slowly transition into the last part of the sine. And this opposite ellipsoid with the concave shape, it will be slowly going in the beginning, and then the last part will go quickly. Doing a simple waveform like this, it's when you get your head around it, it's easy to predict what the outcome will be. But if we go in here and do a random waveform, for example, this one, it will be difficult to predict how the outcome will be. You'll see it doesn't go to -1 and it doesn't go to +1. So we will certainly not see the beginning and the end of the sine. They will not be included here. Let's choose another random one. And here you could, for example, if you don't like these peaks, we could do add a smoothing to it. And again, I would raise the volume, but it's not necessary. So I urge you to play a little with this Phace-Inject, because it can be a bit difficult to get your head around it, how it's worked. But that's the Phace-Inject. I just switch this to left for the second, and then we choose a saw here. Clear it and choose a saw. I just use the simple saw, it's okay. The next on the list is the minimum. And it defaults to say closest to 0, but you can also see where the left waveform is below the right waveform. But let's just keep it here, closest to 0. It will go through the output of each waveform, and then it will choose that waveform that's closest to the 0 line. And you see the sine is starting here at the 0 line, where the saw is starting up here at +1. So for the first part, it will choose the output of the sine. Then when it gets to this point, the saw is closer to the 0 line. So it will instead choose the output from the saw, and it will do so as long as the saw is closer to the 0 line, where this last part, the saw will go all the way down to -1, where the sine will again start to get close to the 0 line. So hence it will favor the output from the sine for the last part. If we instead choose this other option, where we simply see below, then it will not be the one clearest to the 0 line, but it will be the one nearest to the -1 line. And that will, for the first part, be the sine, then the saw, then the sine, and lastly the saw again. And we have the exact same principle with the max. Instead, it will favor the waveform that's furthest away from the 0 line. And you see here in the beginning, the saw is further away from the 0 line than the sine, hence we begin with the saw. Then at this point, the saw will be closer to the 0 line, so it will favor the sine. And then lastly, the saw. And here we also have an option to choose where the left is above the right. So that will mean when we are nearer the +1 line. And here we just see it with a simple a simple saw and a simple sine, but different waveforms will naturally produce different outputs. For example, we can choose sync instead, and then do the minimum. At no point is the sine nearer the 0 line than the sync, so we see the sync all the way. But choosing this other alternative, of course, we'll see a different output, because here the sine is closer to the -1 line. Likewise, if you choose max, with this default setting, the sine is nearest +1 and -1 all of the time, furthest away from the 0 line, hence it will favor that. But instead, choosing this other option, we get this result. Next, we'll look at this nearest. Let's choose the saw again. The previous two examples, it shows the waveform that was nearest the 0 line or furthest away from the 0th line. When you choose this nearest, you are defining which point they should be nearest to. And it begins here at plus 0.99 and minus 99. So we get the same result as if we choose this max one, because it's nearest this line and nearest this line. However, if you choose this nearest line, you can dial in which point the waveform need to be nearest. So as I'm choosing this value, you will see these small peaks. In this case, you will see these small peaks appear. It depends which of the waveform that's nearest to that point I select. For example, if we choose 50, or let's choose 60. Yeah, let's keep it here at 66. So we have an imaginary line about here, and again about here. And then it would favor that waveform that's nearest to that imaginary line, and then we get this result. And again, different waveform will produce different results. Let's keep this one and then dial in a sync here. And as we go through the values, you'll see these different results. And again, here I would raise the volume just because I like to see the waveform that as it would be output. So it would be output to something like this. And if you want to hear it, of course, just double click and choose to play. Here, lower the volume, you can change the octave. And if you want to see, in most cases, I will want to see the samples. I will never output anything with only 300 samples. If I want to keep file sizes small for some reason, I will probably output it with 600 samples. But when I see it with 300 samples, I know there will be a sample in between, because if you start to do more, they'll be very near each other. So even if you plan to output these with 2048 samples, you'll see that you can almost not see the waveform anymore. You only see the samples. But as I said in one of the other videos, what you choose here have no effect how it will sound when you play it back here, and it will have no effect when you output it, when you export it as a sample. It's just a visual thing. And you will not have this button. I only have this in this debug version. So that was the last of the operators. In the manual, I give a few examples where I'm using more than just two partials, but it's just more of the same thing. For example, if I make this one and let's dial in a square, and make it with 48 harmonics. Now I have this part. We have this nearest that operate on these two as seen here. Then we have this operator 3 that operate on these two. It's set to left, so we are basically throwing out or forgetting all about partial 4. And then we have this operator 2 here in the middle that will work on the output from this operator. That's this waveform, and it will work on this output from this one, but set to left it's only partial 3. So I can dial in, for example, a split, saying I want the last half to be that waveform, and that's why I needed to remove that volume. What I can do is, if I want to raise this part, I can go in here and add a volume converter to make this even larger. But now I mix between, I split between the output from here and this one, and I can choose to mix it instead. We have the mix here. And I can dial in a mix, gradually going from one to the other. Or we can do an interchange where I randomly, where I take one step from one segment from the first and then one segment from the last and add the number of segments, or go down here to the random and randomize both which one it uses and the size of them. For example, looking at this, I don't like this peak here. But if I otherwise liked and wanted to use this waveform, what I would do is I said, okay, what I have here is fine. I then resample everything. And that is all of the partials, all of the partials, if they had any phase conversion or value conversion going on in that would be resampled also, and it will all be put in the first advanced of the first partial. So now it's a hand-drawn. I only have this one, and if I edit, I have nothing going on here. It's just a hand-drawn, and I can, for example, this one I can choose what I want. For example, I want an ellipsoid. I want an ellipsoid going from here, and I press shift to here. And now I have a different transition here. Or perhaps I want to make an ellipsoid, or let's do an S-curve. Perhaps an S-curve from here to here. So if you get a result near what you want, then simply resample into a hand-drawn and do whatever you want to it. And now this one, of course, I can start to combine with other waveforms. For example, at a triangle, and then do a mix between those two, or multiply it, or interchange those two, or add them. So the compound waveform is very powerful.